Hi, this is Guntuka Srinivas. Welcome to Varenya's Photon Online Educational Academy for IIT and NEET examinations. I welcome you all for the IIT chemistry classes. In the previous session, we have seen the physical properties and chemical properties of the substances. Let us concentrate on the physical properties. Let us take up the physical properties. Physical properties. Let us go with one by one. First property identified is mass. Mass simply denoted as M. Simply denoted as M. Mass is defined as it is the amount of matter. It is the amount of matter present in a substance. Observe carefully. Mass of a substance is simply defined as amount of the matter present in it. It is the amount of matter present in the substance is known as mass. Clear? No. The mass is always constant for a given substance. Be careful about this sentence. Mass is always constant for a given substance. That means if you take a substance, for that particular substance, amount of matter present in that is always constant. Here, anything. Suppose if you take a mango, example I am telling, if you take a mango, in that particular substance mango, the amount of matter present for that particular substance is always constant. Here, if you take another mango, for that another mango, the amount of matter present in that another mango is always constant for it. That means whatever the substance you take, the amount of matter that is present in it for that particular substance is always constant. Here is the constant for a given substance. Clear? Now, in the chemistry, how do we find the mass? In chemistry, especially in the chemistry, especially in the chemistry, we deal with small amounts of masses. We deal small amounts of masses. Be careful. We deal with the small amount of the masses. That means if you take simply, let us say, sodium chloride, we cannot take a large quantity. We take a small quantity for testing because in the chemistry, the chemicals used are very small in quantities. Yeah. If you are taking anything in the chemical laboratory, the chemicals used are so masses involved in the chemistry for testing purpose are very small. Are very small. Hence, to find out the quantity of masses, to find out quantity of mass, to find out the quantity of mass. Here we make use of use of analytical balance. This is the weighing machine that we make use in chemistry lab to find out mass of a given substance. This machine is known as analytical weighing balance machine. Clear? Now, when you take up the masses, you are measuring all the mass. What is the unit of mass? Unit of mass is kg. Unit of mass is kg, kilogram. In the MKS system, it is the kilograms. Clear? And in the CGS system, it is grams. G stands for gram. This is kilogram. So this is in the MKS system. This is in the CGS system. Already we have discussed the units and dimensions in the physics, IIT physics lectures. So go through those videos if you have any doubts. So grams in the CGS system. Clear? Okay. And if you want minute also, you can use the milligrams. You can use the milligrams also. Milligrams. That is mg, milligrams. Mass, the large quantities in the kilograms, kg, in MKS system. In small quantities, grams, G is the letter. In the CGS system, that is centimeter, gram, and second system. And very, very minute, very smaller quantities, milligrams, mg. These are the units of the mass in which it is expressed. Clear? What do we learn? We learn that mass is nothing but amount of matter present in a given substance. Clear? Let us take up another quantity. Let us take up another quantity. That is the physical property weight. Weight. We denote it as W. W is the letter for the weight. Clear? Now, weight is simply, it is the force exerted by gravity. Exerted by gravity. Exerted by the gravity. Have the clarity in the expression. Force exerted by the gravity. Observe. Weight is equal to M into G. M into G. This is the expression. M into G. Weight is equal to mass. M stands for mass and G stands for acceleration due to gravity. Clear? Weight is completely the force due to the gravity, exerted due to by the gravity. Clear? Gravity impact is present in the weight. Mass is only simple matter. How the clarity and difference between mass and weight. Be clear, mass and weight. Okay. What is mass? What is mass? Mass is amount of matter present. Only M. What is weight? Weight is due to the force exerted due to the gravity. Means gravity effect is present in the weight. When mass is multiplied with acceleration due to gravity, M into G, you will get the weight. But mass simply matter. Amount of. So M stands for mass, mg stands for weight. Clear? That is the weight is a weight force. Okay. Now observe. This weight is not constant. Why? Because gravity, the gravity changes, G changes from place to place. Suppose on the earth, the acceleration due to gravity 9.81. Suppose if you go on the moon, let us say, the gravity effect changes. So gravity effect changes from place to place. Hence, weight is not a constant for a given substance. I clearly write weight W is not constant. Weight W is not constant since there is a change in gravity, change in the gravity from place to place, from place to place. How the clarity? The weight is weight. This weight is not a constant, not constant. Why? Why? Because since there is a change in the gravity from place to place. Clear? Now, what are the units of weight force? Here I clearly write units of weight W. You can, it is a force. So in newtons, capital N in newtons, and it is capital weight force. The gravity. Okay. Sometimes You can express as kg force also. Kg force. Mass into acceleration. So mass with the term mass m, you are taking the effect of g and putting the term as kg force. Clear? So this is nothing but about the weight. Okay. In the chemistry, whenever you come across mass and weight, do not get confused. Okay. Have the clarity between these two. Let's take up the third property. The third property, volume. Right? Volume. V. V is the letter notation. What is the volume? Volume is nothing but the space occupied by a particular substance. Space occupied by a particular substance. Here I clearly write. Amount of space occupied by a substance is known as volume. How do you find out the volume? The amount of the space occupied by the substance. How do you find the volume? Suppose if I want the volume of, if I need the volume of, let us say, a rectangular piece. This is a rectangular piece. Rectangular piece I am showing. I need the volume of it. What I do? I take the length of it. I take the length of it, L, and width of it, B. I take width of it, B. I take the height of it, H. Take the height of it, H. So what is volume? Volume is, in this case, V is equal to length L into width B into height H. This is the simple formula, LBH. Here I have shown a simple rectangular piece, rectangular glass, length, width into height, LBH. This is the entire space occupied. Clear? Suppose, let us say, here I am showing another example. Let us say there is a cylindrical flask. There is a cylindrical flask. Okay. And I want to find out water is completely filled in this. Let us say water is completely filled in the cylindrical flask. Water. This is water. Okay. Let us say the diameter of the cylindrical shape is D, and the height of the cylindrical shape is H. Now, what is the volume? Volume is area. What is the area of circular section? 5/4 d square, or that is in terms of diameter. Suppose in terms of radius, pi r square. So In terms of diameter, 5 by 4 d square. Area into height. Height in this case. So what is the area for circular section? This circular section, circular area, 5 by 4 into d square, where d is the diameter, into height is h. This is the volume. Okay. Suppose if you want to find out in terms of radius, in terms of radius, in terms of radius, r. Okay. Suppose let us say that this is the small r, small r, radius of this circular section. Then volume becomes area. Area in terms of r is what? Circular area, pi r square into h. Right. In terms of radius, volume is v. V is the volume. Clearly, right? Volume. Volume. Okay. That means the complete water, the amount of the space occupied by the water in this case is 5 by 4 d square into h. Okay. Now, what are the units of volume? Units of volume. Units of volume, V. Units of volume, V. Are meter cube. Meter cube. Or meter cube is a large quantity. Or centimeter cube. Centimeter cube is smaller quantity. Further, millimeter cube also in furthermore smaller quantity. Millimeter cube. All these are units of volume. Clear? Sometimes we express the units volume is also expressed volume is also expressed in liters, in the liters. The liters. Yeah. And here I tell the conversion. Here I tell the conversion that 1 liter, 1 L. L stands for liter. 1 liter is equal to 1000 milliliters. 1000 ml. 1000 ml. How that clarity? 1 liter is equal to 1000 ml. And remember, 1 ml is equal to 1 cc. Right. 1 ml, 1 milliliter is equal to 1 cc. Cc in the sense centimeter cube. Nothing but C stands for centimeter cube, cubic centimeter. So 1 centimeter cube. cc, cubic centimeter. This is 1 milliliter is 1 cubic centimeter, and that is 1 cg. Clear? That means 1 liter is equal to 1000 milliliter is equal to 1000. 1 ml is how many? 1 cc. 1000 cc. 1000 cc. Of the clarity. The clarity. And another conversion I would like to introduce is 1 meter cube, 1 cubic meter, 1 cubic meter. 1 cubic meter is 1000 liters. 1 cubic meter is equal to 1000 liters. This is very, very important for all the problems we make use. 1 cubic meter means 1 cubic meter means what? 1 meter. If a tank is available like this, a tank is available like this. Okay. If this is 1 meter, width is 1 meter, this is also 1 meter, 1 meter by 1 meter, and this height is also 1 meter. 1 meter by 1 meter by 1 meter. So this entire thing is 1 cubic meter, 1 meter. In this, what is the total quantity occupied? The total quantity occupied in this is how many liters? 1000 liters. That is the meaning of this. 1 meter by 1 meter by 1 meter. Yeah. In 1 cubic meter capacity of volume, 1000 liters will be present. Okay. And have the clarity that 1 liter is 1000 ml and 1 ml is equal to 1 cc. That means 1 liter indirectly 1000 cc. Okay. Now, have the clarity. You can express the volume in the decimeters also frequently. Volume V can also be expressed in cubic decimeters. Cubic decimeters. Have that clarity. Cubic decimeters. Cubic decimeters notation is DEM cube. Cubic decimeters. This is the notation we use. Okay. Conversion here I tell is, remember all this. 1 liter is equal to 1000. Just now I said 1000 cc or 1000 ml, which is equal to 1 ml is 1 cc, 1000 cc, and 1000 cc is equal to 1 decimeter cube. 1 cubic decimeter is 1 liter indirectly. Have the clarity. Indirectly, 1 liter is 1 decimeter cube. This statement is very valid. Okay. There are 2 things I highlight here. I highlight of the clarity. I highlight once again. 1 cubic meter is 1000 liters. This is the one formula. Formula 1. Clear? The other is that 1 liter 1000 ml and 1 ml is 1 cc, hence 1000 cc, cubic centimeter, which is equal to 1 cubic decimeter. This is another formula. This is another formula. This is the second one. Or indirectly highlight it. 1 liter is indirectly 1 liter is equal to 1 cubic decimeter or decimeter cube. Is it clear? This is the volume that we measure. Okay. And remember, in chemistry, volume, in chemistry, volumes are measured simply by making use of a pipette, burette, graduated cylinders. All these are apparatus. Okay. It may be a burette or it may be a pipette or graduated cylinders. So this is, you might have seen in the laboratory, a small tube. This is a pipette, small tube. This is pipette. Okay. Burette. This is a big tube. Burette. Iron. You can make use of graduated cylinder. Graduated cylinder. This is a graduated means marked. Graduated cylinder. Marked. All the markings will be there. So you can make use of pipette or burette or graduated cylinders to measure the one. Clear? Now, let us take up the another property, density. Let us take up the property, density. The fourth property here I put up is density. Clear? Now, density is of two types. One is mass density. One is mass density. Okay? We denote it as by letter rho, Greek letter rho. The other is weight density. Weight density. We denote it as by letter gamma, Greek letter gamma. Okay. Mass density and the weight density, rho and the gamma. Clear? So first let us see the mass density. Mass density is rho. Mass density is rho, which is given as mass of the substance, mass of given substance by the volume occupied by the given substance. Observe carefully. Mass density rho is simply defined as mass of the given substance to the volume occupied by the given substance. So simply rho is equal to mass by volume. Mass by volume. Okay. Now, what are the units? The units are mass density. Units of rho, mass density is numerator mass kg and volume denominator volume meter, kg per meter. But this kg per meter cube is very large quantity. In the chemistry, we make use very smaller quantities. Hence, we frequently use CGS units. In CGS units, in the CGS unit system, rho is expressed as gram per cc, gram per g, gram per cc, gram per cc. Centimeter cube. Cc stands for centimeter, gram per centimeter cube. Smaller quantities we need to take up in chemistry laboratory because chemical reactions involve very little quantity of chemicals. So that's why density is also very less. So gram per cc. These are generally we adapt. Okay. Gram per cc is the units. Now, let us deal with the weight density. Second is weight density. That is gamma, which is equal to weight of the substance, weight of the given substance by the volume occupied by the given substance. Weight of the given substance by the volume of the given substance. So gamma is weight by the volume. Weight by volume. Clear? Weight by volume. Now, can I write? Just now we have seen, since weight is equal to what? Mass into acceleration due to gravity. So I substitute in place of weight, I substitute this mg. So gamma is, in place of weight, I substitute mg, mg by v, by v. Now I separate these terms. I separate these terms. So m by v, I write one term, into g, I write. Clear? Now observe. What is m by v? Mass by volume. Just now we have seen mass density rho into g, rho g, rho g. That means conclusion is weight density gamma is equal to mass density rho into g, acceleration. So I clearly write in terms of sentence, weight density gamma is equal, this is weight density, is equal to rho, mass density into acceleration into acceleration due to gravity. Acceleration due to gravity. This is rho. This is g. Let me clear. Now, what are the units of weight density? Units of gamma is weight by volume. So units of weight is Newton. Volume is meter cube. So Newton per meter cube. Newton per meter cube. This is Newton. This is meter cube. These are the units, Newton per meter cube. Okay. Have you followed the difference between mass density and the weight density? Now, I would like to ask one question. What is the meaning of having more density? Suppose two substances are given. One substance is having less density, other substance is having more density. What does the density term indicate? The density term always indicates how closely the particles are packed inside. How closely the particles are packed inside. A substance which is having more density means in that particles are closely packed. A substance which is having less density means Particles are not closely packed. Is it clear? More density means particles are closely packed. Less density means particles are not closely packed. That is the physical meaning of the density. Okay, so we have seen about the density. Here I clearly write. Here I clearly write that density indicates density indicates how closely particles are packed in a substance. Clear? Density indicates how closely particles are packed in a substance. Okay, so this is about the density. Let us take up another property. The fifth one is temperature. Clear? Temperature. So temperature indicates the heat, and it is measured. Temperature is measured in three scales. Here I write in the three scales. The first one is degree Celsius. So degree Celsius. This is the indication. Centigrade, degree Celsius. Okay. And the second one is degree Fahrenheit. Degree Fahrenheit. So this is another measurement. The third is Kelvin. K. K stands for Kelvin. So these are the three scales on which temperature of a given substance is measured. Degree Celsius, degree Fahrenheit, and Kelvins. Here, those are the three things. And how do you measure? All of us know that thermometer is used to measure the temperature. Thermometer is used to measure the temperature. Okay. And here, I would like to mention that is in number 1, degree Celsius. In degree Celsius, in the degree Celsius. Clear? We make use In between, we make use scale, in between 0 degree centigrade to 100 degree, 0 to 100. We make use of 0 to 100, 0 to 100. The scale uses 0 to 100. 0 to 100. What is 0 degree Celsius? 0 degree Celsius is the freezing point for water. And 100 degrees Celsius is boiling point for the water. The temperature at which water boils is 100 degrees Celsius. And the temperature at which water freezes, freezing point, is 0 degrees Celsius. That's why degree Celsius makes use of scale in between 0 to 100. Yeah, 0 to 100. I clearly write that 0 degree Celsius is freezing point for water. Whereas 100 degrees Celsius is boiling point for water. The temperature at which water boils is 100. The temperature at which water freezes at 0 degrees Celsius, water becomes freezing point, freezes completely, it becomes ice. Okay, the temperature at which water boils, starting the boils. This is freezing point, this is the boiling. Clear? And coming to the case of second case, degree, about degree, Fahrenheit, degree Fahrenheit. Okay. In this, we make use 32 to 212. 32 Fahrenheit, 32 degree Fahrenheit to 212 Fahrenheit. Scale is in between 32 Fahrenheit to 212 Fahrenheit. Scale is used. This scale is used. When you go for the Fahrenheit, degree Fahrenheit. Okay. Now, here I would like to mention a conversion formula. Okay, I would like to mention a conversion formula. Conversion of temperature given in degree Celsius to Fahrenheit degrees to Fahrenheit degrees. Clear? Observe carefully. You are given the temperature in the centigrades. You need to express in the Fahrenheit. Okay. Then this formula is applicable. This formula is applicable. Okay, this formula is applicable. Now, what is this formula? Here I got degree Fahrenheit is equal to 9 by 5 into degree centigrade plus 32 plus 32. This is the formula. Okay. This is the formula. If you are given degree centigrade, simply multiply that degree centigrade with 9 by 5 and add 32 to it. Automatically, it will be converted into the Fahrenheit. Okay. Example. Let me take up a simple example. Example here I got. Example. The temperature of human body is in Celsius is how much? 37 degrees Celsius. This is the temperature in the human body, 37 degrees Celsius. I want to express it in Fahrenheit, degree Fahrenheit. Express it in the Fahrenheit. How much we want? So we make use of conversion formula. What is the formula? Degree Fahrenheit is equal to 9 by 5. How much I want to convert? 37 degrees Celsius. 37 plus addition is 32. If you simplify this, that becomes 98.6 Fahrenheit. That means 37 degrees centigrade Celsius becomes equal to 98.6 Fahrenheit. This is how we do the conversion. Yes, this is the formula. Conversion. Okay. Now, observe the third scale we make use. The third is what? Kelvin. Okay, denoted by it is the SI system of unit. It is the SI system of unit for expressing temperature. This is the SI system of unit. I clearly write for temperature. Okay. There is a simple conversion formula. Here, there is a simple conversion formula. If you want to express temperature in the Kelvin, that is centigrades, the temperature given in the degree Celsius plus 273.15. This is the formula. If temperature is given in the degree Celsius, add to that 273.15, then automatically you will get this in the Kelvin. Okay, be careful that the Kelvin scale is very much used in the thermodynamics concepts, the measurement of temperature. We need to, in the coming sessions, Boyle's law, Charles' law, etc., where we deal gases. In the gases, we frequently use the conversion of centigrade that is the degree Celsius temperature into Kelvin. This formula is very much useful. Okay. Observe, be careful that below 0 degrees, conversion not possible by using this Kelvin. Maximum is 0. 0 degrees you can convert. Below 0 degrees centigrade, you cannot convert this. Here I clearly write the limitation is that here temperature below 0 degree Celsius, below 0 degree Celsius is not possible in Kelvin scale. In other scales it is possible, but in Kelvin scale it is not possible. Okay, because below 0 you have to add centigrade, say that is the degree Celsius plus 270. Below 0 means minus. Minus it cannot convert. It is not useful. Okay. These are the standard scales in which we make use the temperature measurements for a given substance. Now, I would like to add in general a simple conversions. Here I would like to add a simple conversion. Okay. Now observe, I want to write boiling point of water. Boiling point of water. First one I would like to take a boiling point of water. In degree Celsius, how much it is in degree Celsius? 100 degrees Celsius. Suppose in the Fahrenheit, in the degree Fahrenheit, how much? Conversion, if you convert it, that becomes 212 degree Fahrenheit. Okay. Suppose if I want to convert in the Kelvin scale, how much? Add 273.15 to this. That means 373.15 Kelvin. So here I am putting, here I am highlighting degree Celsius, Fahrenheit. Okay, this is Kelvin. Here, similarly, observe second. I would like to take human body temperature. Human body temperature. In degree Celsius, how much? 37 degrees Celsius. Clear? Now convert it. It becomes in the Fahrenheit 98.6 Fahrenheit degrees. Convert it in the Kelvin, add to this. Then it becomes equal to the 273.15. You add to this. That is 310.15 Kelvin. Human body temperature. Okay. Suppose if I take the room temperature, I want to highlight. What is the room temperature? How much? It will become 25 degree Celsius. 25 is the room temperature. If I convert in the Fahrenheit, it becomes 77 degree Fahrenheit. And if I express in the Kelvin, add to this 25, 273 plus 0.15, then 298.15 Kelvin. Room temperature. 295. The centigrade 273.15 is that. Okay. Let me express the freezing point of water. Freezing point of water. What is the freezing point of water? 0. The temperature at which water freezes, 0 degrees Celsius. Then if I want to express in the Fahrenheit conversion, 32 degree Fahrenheit. If I want to convert into the Kelvin, just 0 degree centigrade at 273. 273.15 Kelvin. So these are the simple standard temperatures always to be remembered. Always to be remembered. How the clarity? These are always to be remembered. Okay. So in this session, what we have seen? In this session, what we have seen? We have seen some physical properties associated with the substances. Number one, we have seen mass. The second property we have seen weight. The third property we have seen volume. The fourth property we have seen mass density and weight density. Generally in chemistry, we make use only mass density. Okay, mass density we frequently use. The last property, what we have seen, temperature. Temperature in the degree Celsius scale, Fahrenheit scale, and the Kelvin scale. And mostly in the gases, measurement of the gases temperature, we make use of Kelvin scale. Convert centigrade, that is the degree Celsius, into the Kelvin. Clear? Hope you have understood the lecture. I think it is a lengthy lecture, but go through the concepts carefully. If you understand the concepts, these will be useful. The basic properties will be useful in the further sessions in solving the numericals. If you like the video, share it and subscribe the channel so that it will be helpful and it will be an encouragement throughout the lectures. Thank you very much.